Hi class. The second factor we're going to take a look at that controls temperature is the type of surface. And so we're going to look at air temperatures that are above or adjacent to water or land. And so let's take a look at the properties of water versus land. We'll put them side by side so we can do a nice comparison between them. And we'll start off with water. So one of the first properties of water is that it's a fluid. And so it's mobile, and being mobile, it can mix. Okay, and we're just going to do all of water first and then take a look at land. Okay, second property of water is that its heat, because it is a fluid, because it is mobile, the heat energy in water is transferred via convection. Now remember from an earlier discussion that convection only takes place in fluids, and the definition of a fluid is any substance in which the molecules are free to move about. So water obviously has molecules where the is a substance where the molecules are free to move about, and so as a result the heat can be transferred in water via convection. Okay. Third property of water is that it is transparent. Okay, now if you live around the area here, if you live in northeastern Wisconsin, don't go using the Fox River as your example of water. Obviously, the Fox River is not very transparent. Think of the open ocean. Okay, in the open ocean, water is fairly transparent, and so as a result, incoming solar radiation can penetrates the surface of the water, and so a greater depth or volume of water can absorb the heat energy. Okay, so solar radiation penetrates and is absorbed. To a greater depth, or by a greater depth. Okay. And so you're warming up from the surface down many feet below. And when we compare that to land, you probably know that land, when solar radiation falls on land, that solar radiation is not penetrating very deep because land's not transparent like water is. A fourth property, the last property that we're going to talk about in terms of water, is that water has a very high specific heat. Okay. If you took science in high school, you probably remember that the specific heat refers to the amount of energy that it takes to warm 1 gram of a substance by 1 degree Celsius. Okay, and so water has a high specific heat, which means that it's going to take a lot of energy to warm that water. Okay. But it'll also hold on to that energy for a long time. Okay. Now, let's now look at these 4 points and look at it from the land's perspective, okay? So obviously land is not a fluid. Okay, so it's not mobile. So there's no mixing that's taking place here. Okay. So any heat energy that is absorbed by the land, it's not mixing. It can be transferred, and that's the next point actually, that over land, any heat that's absorbed by the land is transferred by conduction. So this is a pretty slow and inefficient method of transferring energy. Okay. Now, as I alluded to when we're talking about the transparency of water, land is opaque. Okay. In other words, it's not transparent. Okay. So incoming solar radiation is absorbed just at the surface. Okay. And so being absorbed at the surface is going to warm up quite a bit, but you don't have to go too far down below the surface where things are pretty cool again. Okay? Again, that is because the land surface is opaque and that solar radiation is only being absorbed right at the surface level. Okay? The last point is that land has a low specific heat. Okay? So it doesn't take much energy. I'll put it this way, it does not take as much energy to warm up this substance, to warm up the land. Okay, so when we look at these 4 points, 4 properties of water, 4 properties of land, as a result, when you take a look at all 4 of these points, I'll write it down here. So all of these factors will cause water to warm more slowly. Okay. And store more energy. Okay. And cool more slowly. Than land. Okay. You, I think, already have this by intuition. So especially if you live along the shoreline of Lake Michigan, so Milwaukee, Sheboygan, Manitowoc, Algoma, Kewaunee, those places along, maybe Kewaunee's maybe not along the, oh, it is. Yeah, it is along the lake shore. Okay, but so you already knew this. So in fall, as now we're going into that time of year, fall, transitional period of time. The land is losing its energy very quickly because it has a low specific heat. The water has a high specific heat, so it's been absorbing heat energy throughout the summer and very gradually is giving its heat energy off to the atmosphere. Okay, and so because of that difference in specific heat, you'll often hear the term, going into November and December that, ooh, it's going to be cold tonight. Temperature is going to be down into the 20s, but it's going to be warmer near the lake. Okay, and that's because of the property of specific heat and the water holding on to that heat energy as we head into fall and towards winter. And then as we go spring into summer, you'll often hear at those locations, oh, it's going to be a hot one today. Temperatures are going to be up in the 80s, maybe near 90, but it's going to be cooler near the lake. And again, it's going to be cooler near the lake because of these properties, particularly of the high specific heat. Okay? Alrighty, so there is our discussion on factors that control temperature in terms of the type of surface. And next we're going to take a look at ocean currents.